Hello, in this video we are going to integrate x plus 1 times x minus 1 to the third power with respect to x. We're going to use something called integration by parts. Let's go ahead and work through it. Solution. So the integration by parts formula says if you have the integral of u dv, this is equal to uv minus the integral of v du. And we basically have to pick u and dv and then go through the process. So typically you pick u so that when you take the derivative of u, you end up with something that is much simpler. So in this particular case, we're going to choose u to be equal to x plus 1. That's because the derivative is actually simpler. It's just going to be dx. So du is dx. And we're going to choose dv to be everything else. So dv is equal to x minus 1 cubed dx. And so now we can integrate this. It's very easy to integrate. You could make a u substitution and it would work out quite nicely. So you just use the power rule. So I'll skip the u substitution. So it'll be x minus 1 to the fourth, because you add 1 to the exponent and divide, over 4. Now, if you wanted to see the work for this, I'll do it over here on the side. So if we have x minus 1 cubed dx, I'll use a different variable. You can let w equal x minus 1. So dw is dx. So this integral becomes the integral of w cubed dw, and then so you integrate this and you get w to the fourth over 4 plus a constant, and then w is x minus 1, so you get x minus 1 to the fourth over 4 plus a constant. So this is something that you don't really have to do or show, but I just wanted to show you how I was able to go from here to here without showing any work. Basically, you want to do it mentally. You think about your u, your inside function. In this case, I called it w. The derivative is just 1, so you can just basically apply the power rule. But keep in mind that there is a substitution going on. So if this was like x squared minus 1, it wouldn't be as simple as this. All right, now we can apply the integration by parts formula. I'm going to go ahead and write down the original integral again. So we have the integral of x plus 1, x minus 1 cubed dx. And this is equal to uv minus the integral of v du. So it'll be uv, so this times this. This 4 here on the bottom, I'm going to pull it out and write it as a 1/4. And then we have times the x plus 1. And then we have times x minus 1 to the fourth power. Minus the integral of v du, so this times this. So this is 1/4, x minus 1 to the fourth power dx, just like that. Okay, so uv minus the integral of v du. So this is equal to 1/4, parentheses, x plus 1, parentheses, x minus 1 to the fourth power. Here we're going to integrate again, same idea for this integral. It's basically going to be x minus 1 to the fifth over 5, okay, because we add 1 to the exponent. But when we divide by 5, we're really multiplying it by this 4. 5 times 4 is 20, so this is minus 1/20th. X minus 1 to the fifth power plus our constant of integration. That would be the final and correct answer to this problem. So kind of an interesting problem because it's a little bit different than a lot of the other integration by parts formulas. If you found any value in this content, feel free to hit subscribe if you want to. If not, that's okay. The key takeaway is this is how you use the integration by parts formula, and it's super, super useful. If you want to learn mathematics, I do have courses. They're on my website, mathsorcerer.com or freemathvids.com. Check them out. They're actually on the Udemy platform, but please use the links from my website as it helps me greatly because otherwise Udemy takes a big cut. Plus, I've lowered the prices on all my courses. Again, they're on mathsorcerer.com. So when you use the links from my website or freemathvids.com, same thing, you'll get the lowest possible price because I've lowered the prices. So you should get a good price every time. I've got courses on calculus, algebra, differential equations, and other things as well. Until next time, keep doing mathematics.